Boys and girls, this is Mr. Manise here with another really cool video. In this video I'm going to walk you through how to solve all the problems on the first quiz review in chapter 11 with our polynomials. And my disclaimer is always, yes, I'm going to say this for every single video. Some students may be watching this particular video for the first time. If you have not worked through the problems, please pause or stop the video, go back and work them yourself, then come back and watch the video to make sure you've done them right, or if you get stuck on a couple. You can't sit there and watch me play guitar. If I'm trying to teach you guitar, you have to watch me to get started and scratch the surface, but you got to sit down, put your own fingers on the guitar and play yourself and practice. It's no different with math. So, as customary tradition, I have this little GIF. This is the Clemson football players celebrating their national championship from 2016, and my goodness gracious, that's gotta hurt. Yeah. Oh, but it's awesome. Love watching it. Okay, so here we go. Let's jump right in, and yes, we can use our calculator trick to check these. When they say simplify, that's a lot of what we're doing here with these polynomials. So go ahead and grab your trusty graphing calculator. And these first couple, we're just classifying our polynomials. The first thing we need to do is make sure they're in standard form. Remember, standard form just means that the highest exponent is written first on the left, and we decrease our exponents going all the way down from left to right. So it's saying classify the polynomials. So if we want to refresh our memory, if there is one term, that's called a monomial. Mono means one. If we have two terms, bi, it's a binomial. Three terms, trinomial. If we have more than that, we just say poly. Poly means many, polynomial. So we have two words that classify our polynomials. One word for how many terms there are, mono, binomial, whatever. The second term tells us the actual the exponent. Okay, so it tells me the degree of the polynomial. And we simply, for a monomial, it's a little tricky. If I only have one term, I have to add all of the exponents together. That's a little tricky. Students forget that one. But if I have more than one term, a binomial, polynomial, whatever, I just simply look at the degree of the highest exponent on the left in front of the train when it's written in standard form, and that tells me the degree. If the highest degree is 1, that's linear. Okay. Linear forms a line. Second degree is a quadratic. Third degree is cubic. And then after that, we don't have any fancy sayings. We just say 4th degree, 10th degree, 50th degree, or whatever. Okay. So this first one here is a monomial. And when I have a monomial, you got to remember, you got to add all the exponents. I got to add the 5 plus the 2. So that's going to be a 7th degree. And how many terms do we have? We have 1. So that's monomial. Okay. Second one, how many terms do I have? It's written in standard form. I have apples and oranges. 2 terms, so that's a binomial, and the highest I have is 1. So that is a linear. I know it's pronounced linear. I like to say linear, so your brain thinks, oh, linear. Oh, that forms a line. Linear binomial. Okay, the second is written in standard form, 3, 2, and then nothing. So the 3 means it's a cubic, so the degree is 3rd degree, that means cubic, and we have 1, 2, 3 terms, cubic trinomial. How do you know what a term is? Terms are separated by pluses and minuses. Okay, so that plus and minus separates our terms. Let me blow this up just a little bit. How's that? Is that more better? More better? I'm a math teacher, not English teacher. More better. I don't think that's grammatically correct, but we'll roll with it. Okay, the last one, 11, 8, 3, 1, 0. Okay, so it's in standard form. The highest is 11. So I have 11th degree. 11th degree, and that's 1, 2, 3, 4, 5. That's a bunch. So that's just poly. 11th degree polynomial. Okay, what is the sum or difference? This is good old-fashioned combining like terms. Apples, apples. I can add those together. 5 apples plus 4 apples is 9 apples. And what are my apples? My apples are x to the 4ths. Okay. And guess what, guys? We can check this. Believe it or not, we can check this. Let's use our trusty little trick here. 5x raised to the 4th, drop back down, plus 4x raised to the 4th, drop back down, get some number. And let's type in 9x raised to the 4th. Get some number, and they match. All day, every day. Okay, 60% of the time, it works every time. That doesn't make sense. No. Wonder if you guys know that movie quote. Okay, 12x to the 5th y minus 9x to the 5th y. Apples, apples. Yeah, it's x to the 5th y, but they're apples and apples. So I have 12 apples minus 9 apples. How many apples do I have? I have 3 apples, and my apples are x to the 5th y. Okay, check that one for me, please. Again, for sake of time on the videos, I'm not going to check every single one, but you guys need to be doing that every single time. Okay, write the polynomial standard form. So remember, the highest degree needs to go in front of the train. I got a 2, a 1, and a nothing. Okay, so the 2 goes first. So that should be negative 4x squared, then the 5x. I don't need to write the 1, but you can, and then plus the 3. The constants always go on the back of the train, always. Okay, so that's a second degree. It says classify. Now, I tell you guys, I mean, one of the big things the biggest differences is I see teaching this course all these years is the big difference between A's and B's and C's or even D's is not necessarily not knowing what you're doing, but it's the simple stuff. Checking your answer, careless mistakes, reading directions. I wish I had $1 every time a student missed free points because they simply didn't read the directions. A lot of students will read this and say, write the polynomial in standard form, and their brain stops. Okay, I can do that. I understand form, done. Go on to the next one. We live in this technology world where everything is just jump, 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 zip, zip, zip. Everything's so fast. You got to remember to slow down and make sure you read directions. Okay, this says write in standard form and classify. You got to do something else. We got to classify it. That's the second degree. Okay, so that's a quadratic. And we will get to the big bad quadratic unit here very shortly. Quadratic, and that's 1, 2, 3. So that is a trinomial. Quadratic trinomial. Okay, the next one, I have a cube, and then a 0, and then a 1 and a 1. Okay, I can add these guys. I got 8 apples plus 1 apple. I got 9 apples. Okay, I got to write the highest degree first. It doesn't matter what the coefficient is. Don't look at the numbers when you put it in standard form. Look at the exponents. So 3 is the highest exponent, so he goes first. X cubed, and then I don't have any x squared, so I skip that, and then the x's. 8 apples plus 1 apple is 9 apples, and then I always have the constant on the back end of the train. That's a 3. That's cubic. Don't write second degree or third degree. We got to take all points. That's a cubic. 1, 2, 3. That's 3 terms. That's a trinomial. Okay. What is the simplified form here? Now we're adding another mistake that I see with this stuff in this unit, in this chapter, is students not knowing the difference between when am I adding and subtracting polynomials, when am I combining like terms, versus multiplying, distributing, or using the FOIL method with 2 binomials. You got to look at, see, is there a sign between the 2 different polynomials. In this case, I have a sign here. I'm subtracting these 2 guys. So FOIL, distributive property, none of that stuff applies. This is just a good old-fashioned combining like terms. Now, if there was a plus sign there, then I wouldn't even need parentheses. I would just match up my apples and oranges. But I do have a negative sign, and what do we have to do? We have to distribute the negative sign to every single term. If you do not distribute this negative sign, I will tell y'all mama, and she will be very unhappy. You got to do that, which means I got to flip all these signs. Now this first guy, we'll just leave him alone. Negative 7x cubed plus 5x squared minus x plus 6, flippy flip, flip that guy. Plus 8x cubed, flip that guy. Minus x squared, flip that guy. Minus 3. Okay, now it's time to play the combining like terms game. Apples, apples, apples. Negative 7 apples plus 8 apples. How many apples do I have? 1 apple. I have 1x cubed. Oranges. 5 oranges minus 1 orange. How many oranges do I have? 4 oranges. Bananas. I have negative 1 banana. That's it. I just have minus 1 banana. And I have minus 3 grapes. And that's it. That's all I can do. Now, does this say classify? No. It just says, what does this simplify? Oh, there's that word, guys. There's that word. Simplified. Might help if you can actually see the final answer. Okay. X cubed plus 4x squared minus x minus 3. Let's check it. Let's check it. Please don't turn in your quiz and test. 15, 20 minutes to go. Okay, so parentheses, -7. Make sure you can see this. Zoom back out a little bit so you can see it on the calculator. -7x raised to the third, drop the cursor, plus 5. Now, when I press the X button, guys, I mentioned this on another video, you don't have to press alpha X. There's the X right there. It'll just save you. That'll save you a couple of milliseconds. 5x squared minus x plus 6, close the parentheses, minus this other polynomial, minus the second one, minus -8x raised to the third plus x squared plus 3. Oh, nope, I made that mistake. I didn't drop my cursor back down. So I just pressed the delete button right there. Delete, D-E-L. Just delete. Okay. Minus 8x cubed. It's a cubed. Okay, drop my cursor back down. Plus x squared. And then plus 3. Close the parentheses. Okay, so I've got everything typed in the way that it should be. Okay, fine. 20,000. Type in our simplified answer. X cubed, drop the cursor, plus 4x squared minus x minus 3. Ta-da! Oh, wait. Huh. That's interesting. Let's try that again. I'm not sure what happened there. Parentheses, -7x raised to the third, drop the cursor, plus 5x squared minus x plus 6 minus -8x cubed, drop the cursor, plus x squared plus 3. Okay. And then our final answer, x raised to the third plus 4x squared minus x. Oh, I know what it is. I put a -3. Silly me. Okay, so they match. So this should be So this should be, let's see what I did. See, I caught my own mistake, guys. Look at that. I caught my own mistake. I forgot about this plus 6 here. Plus 6 minus 3, that should be a plus 3. My goodness gracious. See how important that is? See how important? I just illustrated it perfectly. Remember, teachers make mistakes too, guys. I make mistakes. You make mistakes. It's the going back and being willing to check your answers that separate the A's and the B's from the C's and the D's. When I was in high school, I never turned in a quiz or a test before the bell rang without checking every single thing that I could. Okay. And that applies to whatever job that you're going to do, whether you're an architect, engineer, doctor, nurse, or you're flipping hamburgers. Okay? You got to make sure that burger is flipped correctly. You got to make sure that that building is designed properly. Okay, so number 5, what is the simplified form? All right, so here we're going to use our distributive property. I'm going to use my little 3-step process here. Signs, coefficients, and variables. Okay, I got to distribute this -x squared to all 3 of these terms. So get the sign right first. Sign, negative times a positive is a negative. 1 times 2 is 2. Now here, when I multiply x squared times x to the third, that's the product rule that we just worked on last chapter. I got to add the exponents. 2 plus 3 is x to the 5th. Everything builds off of everything else in math. 2x to the 5th. Now I got to distribute it to the 5x squared. Get the signs right. Signs, coefficients, variables. Negative times a positive is a negative. 5 times 1. And then add the 2 plus the 2. That's x to the 4th. And then signs. Negative times a positive is a negative. 1 times 6 is 6. 2 plus a understood 1. There's a 1 there. That gives me x to the 3rd. So my final answer is 2x to the 5th minus 5x to the 4th minus 6x cubed. All right, next one. What is the GCF? Okay, now notice this doesn't say simplify, so we can't really use our calculator trick on this one. You can check that one. Please go back and check that one on your calculator. Now, how do I find the GCF? Now remember, to find the GCF, you're looking for the largest number that divides evenly into all of your terms and the variable with the lowest exponent. Okay, remember the little analogy I used in class with the pencils or the markers. You know, if I'm trying to grab the most number of pencils from every student, the only way to do that is to grab the pencils from the student who has the least. Okay, so I'm looking for the variable with the lowest exponent. The highest number that goes into 8, 12, and 4 is 4, and that's pretty easy. Now, the variable with the lowest exponent is this x to the 1. So the best that I can pull, the best that I can do is just a x to the 1. So my GCF is a 4x. That will divide evenly into all three terms. Now, when you see this word right here, guys, factor, this is going to be huge in our quadratic unit coming up. When you see the word factor or factored form, that means not only do you have to pull out the GCF, you have to figure out what is the other factor that you multiply to the GCF to get back to your original problem. I use this in an analogy in class. If I'm asking for what are the factors of 6, well, you could say a GCF is 3. 3 goes into 6. Well, if I say what is the factored form, the other factor is going to be 2, okay? Because 3 times 2 gives me 6. It's the same concept here with polynomials and quadratics and variables with coefficients. First thing I got to do is pull out the GCF. Okay, 5 goes into all of those. So I have 5. Now the variable with the lowest exponent is this guy right here, the x squared. So I can pull out a 5x squared. Okay, so just like with the 6, I pulled out a 3. I pulled out a 5x squared. Now I got to figure out what is the other factor. For 6, the other factor was 2. For this polynomial, what's going to be left over? Now to do that, the easy little trick that I taught you is take each of these terms and simply divide it by the GCF. How did I get 6? How did I get 2 over here? No, it's just 6 divided by 3. That gives me the other factor. Okay, well, how do I get the other factor over here? I just take the 6, this is like my 6, and I divide it by the 3. So I'm going to take each of these terms and divide it by the 5x squared. And that will give me the leftover, the other factor. Okay. Okay, so now here's where we use our exponent rules. 5 over 5 is 1. This is the quotient rule. 4 minus 2 gives me an x squared. 15 over 5, signs, coefficients, variables. There are no negative signs. 15 over 5 is 3. And then 3 minus 2 is just 1. Signs, coefficients, variables. Sign, negative over positive is a negative. Coefficients. 10 over 5 is 2. And x squared over x squared just cancels. Okay, so my factored form is 5x squared times x squared plus 3x minus 2. So this is like my 3, and this guy is like my 2. 3 times 2 is 6. 5x squared times all of that gets me back to the 6, gets me back to the original problem. So this is my final answer. Can we check that? Absolutely, we can check that. Factored form is kind of like saying, what's the simplified form? So let's type in the original problem, 5x raised to the 4th plus 15x raised to the 3rd, drop the cursor down, minus 10x squared. Get a number, okay, 2 million something. And our simplified answer is 5x squared, parentheses, x squared plus 3x minus 2. Let's see that. Aha, they match. Excellent. Okay, here we got some geometry. It's kind of interesting how this class is called geometry. All right, so this is a triangle. It says write an expression, no equation, just write an algebraic expression for the area of a triangle. Okay, area of a triangle. What is the formula for the area of a triangle? Okay, well, what is the area of a rectangle? What's the formula for the area of a rectangle? Base times height, right? So doesn't it make sense that the area of a triangle, the area of this guy is just half of that? I just cut the rectangle in half. So the area of a triangle is simply 1/2 the base, is 1/2 of the rectangle. 1/2 base times height, okay? So the area, in this case, is going to be 1/2. Now what's the base? Here's the base. 5x squared plus 4x. Okay, that's the base. And then I got to do times the height, times this guy, 2x squared. Okay, now how in the world do I do this? I could distribute the 1/2 Here, I could do that. 1/2 times 5 gives me 2.5, which is fairly disgusting. Okay, not really interested in that. What about this? If I tell you guys, what is 2 times 3 times 4? Associative property of multiplication. Does it matter if I go 2 times 4, then times 3? Could I go 2 times 3, then times 4? Could I do 4 times 3, then times 2? Absolutely, it doesn't matter. It doesn't matter the order. So imagine if this were the 2, the 3, and the 4. Why not, let's be clever, why not we'll just go ahead and multiply the 2 times the 2x squared. That's like the 2 times the 4. 1/2 of 2x squared is just x squared. And now I have the middle term, the middle set of parentheses. Now I can distribute. X squared times 5x squared is 5x to the 4th. Add those exponents. X squared times 4x is, add the 2 plus the 1 is 4x cubed. Okay, so my final answer is 5x to the 4th plus 4x cubed. I never had to mess with this nasty 2.5 stuff. So be smart about the way that you solve problems. You want to make it as hard on yourself as possible. Just kidding. Reverse that. You want to make it as easy as possible on yourself. All right, let's go on over to the next page. Number 9. Number 9. There's that word, simplified. Okay, here we go. When I'm multiplying two binomials, I taught you guys 3 different ways to do it in class. 2 of them are pretty much the same thing, but the third one is the one that had the notorious FOIL method. Okay, and I'm going to tell you, like I told you in class, that 99% of students and teachers prefer the FOIL method. FOIL stands for what? First, outside, inside, last, or first, outer, inner, last, however your preference. So when I multiply, now here again, now this is multiplication. There's no sign in between the sets of parentheses. I'm not adding or subtracting here. I'm not combining like terms. That's multiplication there. So I got to multiply the 2 first terms. X times 3x is 3x squared. Add those exponents. Then I do the outer. X times -2 is -2x. Inner. 1 times 3x is positive 3x. Last is -2. And I'm going to combine like terms almost every single time here. -$2 plus $3 is $1. So I have a positive x in the middle. Always write it in standard form with your highest exponent first. That would be a quadratic trinomial. Okay, can I check that? Can I check foiling? You betcha. You betcha, every time. X plus 1, parentheses, 3x minus 2. Type it in exactly the way you see it. Okay, 3x squared plus x minus 2. 3x squared plus x minus 2. Bam. I mean, you can literally do that in 5 seconds once you get good at this. Okay, next one. First, 2x times x is 2x squared. Outer. 2x times -5 is -10x. Inner. 3 times x is 3x. Last. 3 times -5 is -15. Combine my like terms in the middle. 2x squared. -$10 plus $3 is -$7, and then minus the 15. Check that one for me, please. And the last one here. First, x times 3x is 3x squared. Outer, x times 1 is x. Inner, -4 times 3x is -12x. Last, -4 times 1 is -4. Combine your like terms. $1 minus $12 is -$11 minus 4. Check that one for me, please. Okay, write an expression, not an equation, the algebraic expression for the area. There's a trigger word. Geometry is full of trigger words. Okay, so area. Okay, so I'm thinking, we just talked about that. That's just base times height. So it's just base times height. So I'm just going to simply do the FOIL method. It doesn't matter which one I write first. 2 times 3 is the same thing as 3 times 2. So I'll do base 7x minus 2 times 3x plus 4. I'm going to use the FOIL method. You can use the box method if you want, but I'm just telling you guys, when you get to advanced algebra next year and your teacher says FOIL this out, you're not going to have time to do that box method. Not with a trinomial times a trinomial times a polynomial or whatever. So you really do need to get accustomed to this distributive property foiling method. Alright, so first, that's going to be 21x squared. Add the exponent. Don't ever forget to add those exponents when you're foiling. Outer, that's plus 28x. Inner, minus 6x. And last is negative 8. Alright, so combine $28 minus $6 is $22. And then minus the 8. Can y'all see that? There you go. 21x squared plus 22x minus 8. Okay, check that one on your calculator for me. Alright, now here, this one here, we can't use the FOIL. FOIL only works with two binomials. And here I've got a binomial times a trinomial. But the distributive property idea, the strategy still works. Now, me personally, I like to put when I have a binomial times a trinomial, I like to put the binomial first. That's just a personal preference. You don't have to do that. Here I use my little silly analogy that we talked about in class of I've got my plants and I've got what do plants need. These are my plants, 1, 2, 3 plants. I need water, sunlight, soil. I've got to get water to all my flowers, and I've got to get sunlight to all of my flowers. So I have to do this 6 times. So x times x squared is x to the third. Add those exponents. Get water to that flower. X times 5x is 5x squared. Water to that flower. X times negative 6 is minus 6x. Okay, get sunlight to this flower. Negative 2 times x squared is minus 2x squared. Sunlight to that flower. That's minus 10x. And sunlight to that flower. Negative times a negative is a positive. Okay. Alright, so now it's time to combine apples and oranges. Apples. That's the only apple I have. Okay, 5 oranges minus 2 oranges is 3 oranges. And I have negative 6 bananas minus 10 bananas, that's negative 16 bananas. And then I just have 12 grapes. Okay, can I check that one? Uh-huh. Let's check it. Okay. So, parentheses, x squared. Make sure y'all can see this. Okay. X squared plus 5x minus 6. Close the parentheses. Open up a new set of parentheses. X minus 2. Close the parentheses. And let's get a number. Okay. And we're saying that's the same thing as x raised to the third, drop my cursor down, plus 3x squared minus 16x plus 12. Ta-da, they match. On to the next one. Okay, this is one of our special cases. Now remember guys, with the special cases, you don't necessarily have to know them to be able to get the correct answer. Depending on how the question is worded on the test or on the EOC, they may force you to know how to do this, so we do need to know the rules for those purposes, but at the end of the day you could simply just FOIL this out if you wanted to. X plus 3 squared, you could just write x plus 3 times another x plus 3 and FOIL it out, but if you remember the rules, all I do is when I'm squaring a binomial, I square the first term, I square the back term, and those are my first and third terms. To get the middle term, I multiply the first term times the second term, and then I double it. So when I square the first term. Okay, so x times x is x squared. I square the back term. 3 squared is 9. Okay, so those are my first and third terms. To get the middle term, I multiply 3 times x, which is 3x, and I double it, which is 6x. So that gives me x squared plus 6x plus 9. Okay, if you don't like that, you can FOIL it out. X plus 3 times another x plus 3. First, x squared. Outside is 3x. Inside is another 3x. And now you can see that's why you double it, because you're always going to get these. You're going to get 2 of these guys every single time when you have one of these special cases. And then last, 3 times 3 is the 9. And of course, when you combine, you get the x squared plus 6x plus 9. It's a little bit longer way, so if you know the shortcut, then that's just kind of saves you some time there. I can check that. Let's see if I can check that in 5 seconds. 1, 2, 3, go. X plus 3 squared. X squared plus 6x plus 7. Did I do it? Oh, maybe that was like 6 seconds. Okay, so home stretch here. Got some more figures and shapes that, yes, we will eventually get to in geometry, believe it or not. What is the area of the shaded part of the figure below? So this is kind of hard to see, but of course this is the shaded region. So anytime in geometry where they ask you about these shaded regions, you're almost always, every single time, you're going to do the area of one thing minus the area of the other thing. Okay, so in this case, they want the area of the shaded, which is on the outside. So I need to do the area of the large square and then find the area of the unshaded square, and I just subtract the two. Okay. All right, so how do I find the area of the big square? Length times width, base times base, or base squared, however you want to think about it. All sides of a square are the same length. So that's simply going to be x plus 8 squared. Okay, now this is one of our special cases. Okay, so what do? Square the first term, square the back term. 8 squared is 64. Multiply the two. 8 times x is 8x, and double it. So there's going to be a 16x in the middle. Okay, plus the 64. Okay, so that is the area of big. I'll just call that area of the big square. Okay, now I need the area of the little square. The area of the little square is just the same thing. It's going to be base times base, length times width, base squared. So that's just going to be 2x times another 2x. And that's just simply going to be 4x squared. That's area of little. Lil, L-I-L with apostrophe, lil. Okay, so the area of the shaded region is going to be area of big minus area of lil. Lil. Okay, so my big area is x squared plus 16x plus 64, and then from that I'm going to subtract the area of the little square, which is negative 4x squared. So now I've got apples. $1 minus $4 is negative $3. Bananas, 16 bananas, and 64 grapes. And that's all she wrote, boys and girls, for that one. Okay, last one. What is the simplified form of x squared minus 10 times x squared plus 10? This is another one of our special cases. This is a difference of squares. How do I know it's a difference of squares? Because the first terms are the same, the back terms are the same, and one of my binomials is negative, one of my binomials is positive. When you have a positive and a negative, if you were to FOIL this out, you would see that the two middle terms, instead of combining like terms, they would offset each other. They would cancel each other out. So all you have to do with the difference of squares is square the first term. X squared times x squared is x to the fourth. Okay. You just add those exponents together. And then I square the back term. 10 times 10 is 100. And I throw a little negative sign in there. That's it. Now I have a difference of squares. Square the first term, square the back term, throw a minus sign in the middle. Okay, and that's all you have to do. I'll do this real quick just so you can see. If you FOIL this out, x squared times x squared is x to the fourth. Oh, excuse me. X to the fourth. Outside is going to be plus 10x. Inside plus 10x squared minus 10x squared. And then last, negative 10 times positive 10 is a minus 100. And then you can see $10 minus $10 just cancel, and you're left with x to the fourth minus 100. So you get the same answer, but if you know the shortcut, the special case rules, and just makes your life a little bit easier, shorter. Hope you guys enjoyed this video. Hope you cleared out any misunderstandings or errors that you may have made, and we will see you on the next one.